Welcome all of you to this video of Maths Made Easy. Now in this video we are going to take up complex numbers. This is from today I'm going to post some videos on complex numbers, very easy scoring topic. So see to it that you don't miss any questions from this chapter in your exam. Okay, so complex numbers is some new chapter that is introduced in 11th standard. You didn't have anything like it in till class 10. So let's see. Now, supposing when you have done this root 25 in 10th standard, if I asked you this root 25, what would you say? You would say plus 5 minus 5, okay? Why? Because plus 5 into plus 5 is a 25 and minus 5 into minus 5 is also a 25. So the square root of 25 is this. Similarly for root 9 it is plus minus 3. Okay, but now let me ask you something. Have you ever thought of this? Have you ever thought of this? Okay. So, have you ever thought what is the value of root minus 25? Now, some of you will say root minus 25 is equal to minus 5, which is wrong. Because minus 5 into minus 5 will again give you 25. So, it is not a root minus 25. Then plus 25 also doesn't work. Then you can't say one of them minus and one of them plus. Then it is not the root. In root, both have to be the same. Okay. So, this is not these are not roots of plus minus, these are not roots of minus 25. So what happens is whenever we get root of a negative number, now we can write root minus 25 like this, minus 1 root 25. Okay, so once we can write like this, we can say, now in 11th standard they gave a new name to this root minus 1, which is I. This is where imaginary numbers start in 11th standard, okay? And then it is root 25, okay? So, root minus 25 is I root 25. What is I? Let's talk about I little bit, okay? Because I is new for you all. So, I is equal to minus root 1. Then I square is equal to, square this, I square is a minus 1. Okay, if I want I cube, then it is I square into I, which is, this is minus 1 already, minus 1 I, that is minus I to the power 4 is I square into I square, okay, which is minus 1 into minus 1, which is a 1. So, like this you will have to keep finding the values. So, let's do a few sums. So, when you were doing real numbers, okay, when you did real numbers in 10th standard, then the number system, the entire number system, okay, the entire number system is divided into two parts. One is real numbers and one is complex numbers. That is what we are going to do now. Okay, real numbers and complex numbers. This you had been doing till class 10, right? You were doing this till class 10. You had natural numbers, you had integers, you had rational numbers, you had irrational numbers. Okay, so everything came under this. All together, integers, rational numbers, irrational numbers, whole numbers, natural numbers, everything was under this. Okay, we are now starting with this complex numbers. Okay, now if they tell us find the value of I to the power 38, okay, what do we do? I to the power, we'll just square and then we'll take how much? I square to the power 90, okay. So I to the power 36 and then I square, okay, I square to the power 18, that is I to the power 36 into I square. That is how much? This is minus 1. Minus 1 to the power an even number. Okay, that is 1. Okay, and this is minus 1. So my answer is minus 1. I to the power 15, supposing they tell us to find. Okay, I to the power I square to the power I to the power 12, and then I to the power 3, I square, and then 6 I 3, I square minus 1 to the power 6 I square into I. So there's no fixed rule. I'm just splitting it as per my convenience. Then I to the power minus 1 to the power 6 is a 1 because it's an even number. Okay, this is a minus 1, yeah, and this is an I. So minus I. So you can have minus I, you can have I in the final answer as B or in BI form. Okay, that means we write complex numbers like this, A plus IB. Okay, where A is a real number, B is a real number, but this is the imaginary part, this is the real part. Okay, now what they are saying is express as B, that is expressed as a real number only, or as a combination of real and imaginary like this. So let us see the sums. 3i dot 2. Now this is very simple, 6i means the BI form. Okay, next sum. Minus I and again minus I. This is plus I square, which is a minus 1. This is the B form. Okay, minus root 25, which is equal to root 25 root minus 1, which is 5I. Now x by I, what do I do for this? How do I write in either B or BI form? Okay, x I into I into I. You have done it with numbers many times, right? X I into I square, which is x I and minus 1. Okay, so this minus 1 goes up here. Minus root 20 plus root minus 12. How to do this? Remember, the minus is inside the root sign. So how do we do it? Okay, so this is 20 root 20 and I, because it is minus root 1 plus root 12 and then again I, which is, now here it is 4 into 5. So 2 root 5 I plus this is 2 root 3 I. I can write it like this, root 5 plus root 3 I. Okay, I can write it like this. So I have got it in the BI form. Now there can be many types of sums, simplify and get the B or BI form. I'll tell you all something, whenever you have such big questions, do one thing, because initially you will keep forgetting how to you know how to manage, and you'll keep forgetting. So at the top of your notebook, just write this and write this much, right at the top right hand corner of your notebook, so you'll remember whenever you're doing a sum. Now how do we simplify this? This is very complicated, बहुत ही complicated है. तो इसका क्या करते हैं? Here we will first ignore this, okay, and we'll try to work in the inside of the bracket. So here I square and to the power 9 plus 1 by 1 to the power 25 is 1 only. Here I is I to the power I square to the power 11, 22, okay, 12, I to the power 12, I square to the power 12 into I. This is I to the power 24 plus 1, 25. Close the bracket. Okay. Now, this is minus 1. So, to the power 9 is a minus 1. And here plus 1 by, this is 1. Here I. Okay. Cube. This is minus I plus 1 by I and then cube. So we have really simplified it. Okay, further little bit more, this is minus I cube plus 1. Now I am using the formula a plus b whole cube plus 3 minus I square plus 3 I, because I and 1 square, okay, by I cube, okay, by I cube. So a cube plus b cube plus 3a square b plus 3ab square. Now what to do? I'll have to work on this. Now this minus I cube has to be like this, okay, because this is a, full minus thing is the a, which is equal to minus remains minus only, okay, and I cube is I square into I, which is minus I, okay. So minus I cube minus remains, and with this minus I, that is a plus I cube is a minus I, and with this minus it's a plus I, plus 1, and then a cube plus b cube plus 3a square b plus 3a, I need a minus here, b square is a 1, okay. So here minus I cube, the minus will remain because of the cube, okay, and then I square is a minus 1, so it is just an I, plus 1, this is minus and minus, plus minus 3, because minus goes because of square, and then one more minus comes because of I square, so minus 3I by I, only I, because I by minus I. So I have minus 2I minus 2 by minus I, which is equal to I minus 1 by I, okay. So I plus 1 by I, what is that? Now minus 2, and here I have a minus, so 1 plus 1 by I, okay, 2, 1 plus, this is if I multiply with the I here and 1 I here, okay, then how much do I get? Plus I by I square, which is 2, 1 minus I, okay. So this is my final answer, simplified form. Now if this is simplify this, what to do? Okay, so I can see one I here, so root 5, then root x to the power 8, and then root minus 1, okay, minus root 20, root x to the power 8, and then root minus 1, okay, plus root 45, then root x to the power 8 and root minus 1, okay. Now how to simplify this? This is I, okay, the minus 1 is an I. Now I have a root 5 here, x to the power 8, root x to the power 8 is x to the power 8 into half, any square root is a into half, okay, x to the power 4. So here I can write x to the power 4 I minus, now root 20 is a 4 into 5, which is 2 root 5, minus 2 root 5 x to the power 4 and I, okay, plus then root 45 is a 9 into 5, which is a 3 root 5, so 3 root 5 x to the power 4 and I, okay. That is, now I have root 5 and x to the power 4 in all of them, that I will take out, so root 5 x to the power 4, and I also I will take out, 1 minus 2 plus 3, that is equal to root 5 x to the power 4 I, this is 4 minus 2, which is a 2, okay, so 2. So root x to the power 5, x to the power 4, I is my simplified answer. Prove. You have to prove that this is equal to x to the power 4 plus 4. Okay. This is, you can see, this is completely real. No imaginary number is here in this. How to do? Now if you see this much and if you see this much, okay, you will observe something here. What do you observe? Okay, here it is a plus b, a minus b. So I can write like this. Bracket. Again. Okay. So now I'll work on this. So x square, a square plus b square plus 2ab minus 1. So it is a plus 1. Now a square plus b square minus 2ab minus 1 plus 1. Okay. So if I rearrange it little bit, plus 2 plus 2x. Okay. And minus 2x. Okay. So x square plus 2 square minus 2x square. Yes. This is, now you see we have already reached fully real numbers. No imaginary number. Imaginary number has stopped at this stage only. Okay. So we are moving towards this. X to the power 4 plus 4 plus 4x square minus 4x square, from this minus 4x square. This cancels, x to the power 4 plus 4 right hand side, hence proved. Okay. So we have to use the identity. A square minus b square is a plus b and a minus b. This is what we used 3 times. Now let us talk a little bit about modulus of a complex number. Okay, what is modulus of a complex number? Now, just like we have the xy plane, we also have the complex number plane. Now, supposing this is the x-axis and here this is the real number axis, this is the imaginary number axis, okay, the y-axis. Then supposing the complex number here is a comma b, okay, then this distance is, we write a plus ib, right, is equal to z. So this one is, this portion is root a. This portion, this is mod a, this is mod b, okay. And if I draw this becomes the modulus, this distance becomes the modulus, which is root over a square plus b square. So we are going to do sums on this, finding modulus of a complex number. So sometimes they will give us little complicated questions and then ask us to find modulus. Like, now I want to tell one thing here, we will discuss this later. Supposing the complex number is a plus ib. Modulus of the complex number z is this. Okay, modulus of, now there is something called conjugate. Now if z is this, z bar is a minus ib. You just change the sign. Okay, and modulus of z bar is again same as this. Okay, we'll do the properties later. Now only for the sum I am telling you. So you have to remember this. X plus iy is equal to u plus iv, u minus iv. Prove that x square plus y square is equal to 1. Okay. So this is given to us, we have to prove this. How do we prove this? What we do is, we take mod both sides. Okay, these sums are done by modulus only. So I am taking mod both sides. Okay, and then This I will split into two parts, numerator and denominator. Okay. Now mod of this one is root over x square plus y square. Okay. And the mod of this is, I'll write it in the next step, root over u square plus v square. Again, the conjugate is also u square plus v square root over. This is x square plus y square. Now, is equal to 1. What do I get? Do the square of this. Okay, hence we have got what they had asked us. So these are sums. 3 plus 2i. We'll have to find the mod of this. Okay, so what we'll do is 3 minus 2i, here we'll multiply just to remove that denominator. Here 3 minus 2i. Okay, so now how much do I get? Here if I multiply, I get a 6 plus 9i minus 4i minus 6i square. 9 minus 4i square. This is plus 6. Okay, I get a 12 plus 5i. This is 9 plus 4, which is a 13. 12 plus 5i. This is 13. Okay. So how much do I get now? This is 12 by 13 plus 5 by 13i. Now this is my complex number. I still have not found the modulus. Now mod of this is, mod of this number, if I take this as a z, then mod z is equal to this 12 square by 13 square. Even if it is a fraction, don't worry, you can find by squaring the a and b. So 5 square by 13 square, which is 144 by plus 25 by 169, which is equal to 1. Okay, so this is my modulus. So the modulus of this complex number, this much, is equal to 1. 1 plus I, 1 minus I, minus 1 minus I, 1 plus I. Now, this is, you have to find the mod of this. 1 minus I, 1 plus I. 1 plus I whole square minus 1 minus I whole square. Okay, so I am just treating it like an LCM sum, LCM addition. 1 a plus b whole square plus I square plus 2i minus 1 plus 2i minus I square. 1 minus I square. This is a plus b, a minus b. Okay, that is 1 minus 1 minus 1 minus I square. Okay, plus I square minus I square. 4i by, this is 1 plus 1 because minus and minus. So this is 2i. So my complex number, this number has been reduced to 2i. Real part is not there at all. Real part is not there. So modulus of this is root over 4, which is a 2. Okay, only b square. Express as a plus bi. So express as a plus bi. That means this complex number, it has to have one real part, then one imaginary part, and then I. Okay, so what to do? So what I'll do is, I'll just extend this little bit and inside only 2, don't do it outside, then it will have a different meaning. Okay, you have to do it under the root side. Whatever you are trying to calculate and rationalize or whatever you are doing. Okay, so do it inside the root side. So now 5, 2 plus I square, 4 minus I square and a root over. Yes, Now this comes out 5 2 plus I square 4 plus 1. Yes, this is minus and this becomes 2 plus I comes out of the root sign because it is already whole square. This and this 4 plus 1 and 5 gets cancelled. So my answer is 2 plus I. This is my A plus IB formation. Okay. Next question, let's see. So this is my next question. I square is a minus 1. Okay. So minus 4I minus I by 2I plus 1. This is a square which is minus 5I and 2I plus 1. This is a square which is 25I square by 2I plus 1 whole square. Okay, that is minus 25 by 4I square plus 1 plus 4I, which is minus 25, and here minus 4, this is minus 3. Okay, minus 4 minus 3, it becomes with this plus 4I, right? Minus 3 minus 4I minus 3 minus 4I. Okay, so that is minus 25 minus 3 minus 4I. Now this is 9 minus 4I square. 9 minus 4I square. This becomes a plus 4. 9 minus 4I square. Okay, so that becomes minus 25 minus 3 minus 4I by, this is 9 plus 16. 4 square will give me a 16 and I square will give me a minus 1. So this is again 25. Okay, 9 plus 16 is a 25. Cancel this. So my final answer comes to, if you multiply with the minus, 3 plus 4I. Okay, this minus gets multiplied here, 3 plus 4I. Okay. So those were few of the questions from complex numbers. We did few questions from modulus. We did few questions from right in the form of a plus bi. We did few questions in simplification of complex numbers. In my next video, I am going to take up properties of complex numbers, or properties of modulus of complex numbers. Okay, and then after we talk about the properties of modulus of complex numbers, we are also going to take up sums based on the properties of modulus of complex numbers. Okay, so if you have liked the video, do not forget to like, share and subscribe. Thanks all of you. Bye then.